Welcome back. In this video, we are going to begin to explore the concept of probability. Our first objective will be to find a sample space. Before we do that, we will define some vocabulary. Then we'll define probability. We'll find the probability of an event, and we will take a look at random selection. First, let's begin with some vocabulary. An experiment is any happening whose result is uncertain. Like flipping a coin or rolling a die, we're not sure what we're going to get. Outcomes, those are the possible results of an experiment. So when we flip our coin, it will land either heads or tails. When we roll our dice, we could roll a 1, a 2, a 3, a 4, a 5, or a 6. The sample space is the set of all possible outcomes. You'll hear me talk about those as the possibilities. Example, all the possible outcomes from flipping a coin some number n times. An event is any subcollection of the sample space, usually referred to as the winners. If the probability of an event is exactly 0, that means the event cannot occur, or we'll call that an impossible event. If the probability that an event is 1, then that event must occur, and that would be considered a certain event. In our first sample here, we want to find just the sample space for the following experiment. So we're going to want to take a systematic approach to this. You toss a coin twice and a 6-sided die once. So I toss my coin, but I toss it twice. It's going to come up either heads or tails. And then I roll my die, and I can roll a 1 through a 6. So if we think about this, I've got my first toss, up it goes, lands heads. I've got my second toss. It could land, again, heads or tails. It lands heads again. And then I roll my die, and it could land 1 through 6. It lands 1. I'm going to go through this as if the first flip of my coin was heads, the second flip of my coin was heads, and then I rolled a 1, a 2, a 3, a 4, a 5, and a 6 on my die. So that's going to be listed here as heads, heads, 1, 2, 3, 4, 5, 6. But then, maybe on my first flip of the coin, I lands heads, but on the second one, it lands tails. So I could have heads, tails for my flipping of my coin for my 2 flips. And then maybe roll my dice 1, and then it's 2 and 3 and so forth. Heads, tails 1, heads, tails 2, heads, tails 3, heads, tails 4, 5, and 6. Then the other possibility, tails, heads on my 2 coin flips. So tails, heads 1, tails, heads 2, 3, 4, 5, and 6. And then tails, tails on my flips. Tails, tails 1, 2, 3, 4, and 5, and 6. So it turns out there's 24 possible outcomes from this particular experiment. So that would be my sample space. All of those 24 are listed out. Our second objective is to define probability, calculate the probability of an event, count the number of outcomes in the event and in the sample space. Then the number of equally likely outcomes in an event E is denoted by n of E, or n parentheses E. And the number of equally likely outcomes in the sample space, S, is denoted by n sub S. So outcomes in an event, n sub E, and our sample space, or the total, is n sub S. So the probability that an event will occur is given by n of E divided by n of S. You'll hear me talk about that as the number of winners divided by the number of possibilities. So the probability of an event is n of E divided by n of S. The probability of an event is going to fall somewhere between 0 and 1 inclusive. And as we saw in our vocabulary, if the probability of an event is 0, it's an impossible event. If it's 1, it's a certain event. If the probability is exactly 0.5, there's an equal or just as likely and unlikely possibility that that event occurs. Sometimes you hear that referred to as 50-50. In our second sample, what is the probability if we toss a coin 3 times in a row, or we toss 3 coins? What is the probability that all 3 land tails up? Every time we toss a coin, there's a 1 in 2 chance that it lands tails up. Toss 1 is 1 out of 2, toss 2 is 1 out of 2, toss 3 is 1 out of 2. So the probability that all 3 land tails up is 1 out of 8. In our second sample, we're asked to draw 1 card at random from a standard deck of playing cards. So our standard deck of playing cards has 52 cards. There are 4 suits: diamonds, hearts, spades, and clubs. So 13 of each of those. What is the probability that that 1 card that we draw is a diamond? There are 13 diamonds out of a total of 52. So 1 out of 4. That doesn't really look like a 3, but it is. Our third objective, finding the probability of an event, show that the probability of rolling any particular number of a 6-sided die is equivalent to rolling that same number on a 12-sided die. So recall our 6-sided die has the numbers 1 through 6, while a 12-sided die has each of the numbers 1 through 6, but twice. So that should say 2 of each of the numbers 1 through 6. So it's going to have 2 1s, 2 2s, 2 3s, and so forth. 12-sided die, you have a 2 in 12 chance of rolling a particular number, whereas in a 1-sided die, you have a 1 in 6 chance of rolling that particular number. So 1 out of 6 is indeed equal to 2 out of 12. The probability of that happening on those die are the same. Some other helpful probability scenarios. Back to that standard deck of cards we saw earlier. There are equal number of hearts, spades, clubs, and diamonds. It's a standard deck. The numbered cards are 2 through 10, plus your quote-unquote face cards are ace, jack, queen, and king. So there's no 1 in a deck of cards. Objective 4, random selection. Let's take a look at this particular sample. The numbers of colleges and universities in various regions in the United States in 2012 are shown in the figure. 1 institution is selected at random. What is the probability that that institution is in one of the 3 southern regions? In order to figure out this probability, we're selecting 1 at random, but out of all of these institutions, we have to add up all of the schools, the 640 in the Pacific, the 342 in the Mountain, and so forth. That is the total of all the regions is the 4,706. The chance that we pick a winner, or there's 876 in the South Atlantic, there's 308 in the South Central, and there's 447 in the West South Central. So if we pick one of those, that would be a winner. So there are 1,631 possible winners. The 447 plus the 308 plus the 876. Any one of those would be a winner. So our probability is 1631 divided by 4,706, or 0.347. So that wraps up our introduction to probability, and we'll get some more practice with this when I see you in class.